Good afternoon. So in today's video, I'm going to introduce you another method called substitution method. Now, the only thing challenging about it is looking for that opportunity to use this method. Okay, and so we're going to go over as to when can I use substitution method. Okay, so first of all, what do we mean by substitution method? Well, if you remember from previous problems, oops, that should be an X. And then you're given x equals 4, y equals 0. Well, substitution literally means this. Replace x with the value of 4 and replace y with the value of 0. That is it, substitution. So, I would rewrite this expression as 3 times 4 plus 0 minus 8. Notice that now all my variables are assigned to specific values because they gave them to me, and now I can go ahead and simplify, and I get something that looks like this. Okay, and then the answer I think is 4. But the goal here is to understand the idea of substitution. You've been using it before with expressions. So let's look at an equation. Let's say I have 2 times an unknown value plus y equals 10. And let's just say that they give us x is equal to 4. Okay? Well, in this case, again, one of the variables, they are giving us the actual value. So I'm going to use this concept or idea of substitution. And so I'm going to use this little arrow pointed out and say I'm replacing x with 4. And since there's 2 4s, that means I'm multiplying 2 times 4, and I rewrite my equation as this. I still have one variable here, that's fine, but I have a value for this variable. So I can still figure out the answer for this because I'm given a number. 2 times 4 is 8, plus y equals 10. Move this up a bit. I subtract 8 from both sides, or take away 8 from both sides. I have a 0 pair. This is positive y, and I'm left with 2. So now my answer is, for this equation, x equals 4 when y equals 2, and that would equal 10. Again, just using the idea of the word substitution. We haven't really jumped into substitution method, just the idea. Okay? Now, well, what happens if I'm given 2 equations? And let's say we're given the same equation, and we're told that y equals -6. I got 2 equations. This is still an equation. Why? Well, if I graph it, my output will always be -6. So I'm going to have a horizontal line that crosses the y-axis at -6. So it's still considered an equation. Okay? Now, the substitution method, remember the previous examples? I'm still applying the same thing. I notice, hey, these 2 variables represent the same thing, whatever y is, the unknown value, and because y is equal to -6, I can go ahead and come up to this equation and apply the substitution method. 2 times x plus -6, and I do this because I don't want to make a mistake right off the bat with the signs. So I'm going to be very cautious about this. Now I'm going to rewrite this as 2x minus 6 equals 10, and then I go using my algebraic methods. Add 6 to both sides. 2 times x equals 16. Undo multiplication, and I'm left with x equals 8. What does that mean? That means for this system of equations, they intersect at one point, which is at 8, -6. Because I already have what y is, I just had to figure out my input x. Okay? And these are my 2 answers. Algebraic. I don't know if it's in the screen. Algebraic, and this would be geometric, and I'm just going to abbreviate. Okay? So, let's do one more example that looks slightly a little more complicated. And again, the idea is you're looking for when to use substitution method. If I'm given 2 equations, and I'm given some sort of a value or an expression that represents one of the variables, then I can switch around. This one was pretty simple. Okay, but what happens when it looks like this? So we're using the same instructions. Solve this system of equations using the substitution method. Again, I notice that I have an isolated variable that equals an expression. Unfortunately, it's not just a constant like it was previously, like a number 6 or 4 or 5 or even negative 13. It's x minus 13. So how does that change how I apply this? It doesn't. We still notice that, hey, these two variables are identical, y, and I know that y has a value of this expression, some number minus 13. So what I'm going to do is replace the y with this expression. So what's it going to look like? I'm going to slightly write it over here. 4x plus 2, now here we got to be careful, times whatever the value of y is. Well, the value is this expression, x minus 13, okay, equals 10. All right, so if you want to pause right now the video and kind of go back and see how I did this, again, these two variables are identical, y, and this y has an actual value of this expression, x minus 13. We don't know what x is, but by substituting this variable with this expression, notice that my equation now has only one variable. So remember, this y variable is equal to that y variable, and we know that this y is equal to this expression. Because this relationship is stated here, we can also say that this y is equal to x minus 13, which allows us now to use the substitution method. 2y is now 2 times x minus 13. And now I continue with distributive property. And then I get 4x plus 2x minus 26 equals 10. I combine like terms and I get 4x plus 2x equals 6x. Minus 26 equals 10. I add 26 to both sides. I'm left with 6x equals 36. I divide both sides by 6 and I'm left with my solution, x equals 6, which is my algebraic solution here, just x equals 6, and my geometric solution, which is this, 6, negative 7. And if you want to give it a shot, see how I figured out what the output is without graphing, because I did not graph. But if you can't, don't stress it. Just go back to Desmos, graph both equations, and you should get this coordinate point. Okay? And that is how you use substitution method for system of equations. Okay? All right, until next time. Bye.